Hey everyone, it's Miss Lloyd again. We are looking at trig functions of general angles, meaning we're going to be putting some points on the coordinate plane and using our special right triangles, the 45, 45, 90, and the 30, 60, 90. So when we're looking at the trig functions, the basic six, looking at the sine, cosine, tangent, cosecant, secant, and cotangent, which are the reciprocals of the first three. Because in my last video, we talked about we've talked about SOHCAHTOA and the opposite over hypotenuse, and how when we are in the coordinate plane, our opposite is always going to be that y value, and our adjacent is always going to be the x value, which means that our hypotenuse is going to be our r. So all of these we're changing. Instead of adjacent, hypotenuse, and opposite, we're using x, r, and y in this case. And because sometimes we have x or y in the denominator, we do have to be careful about when those values are equal to 0. If they're in the denominator as a 0, we would have an undefined function. And since we're looking at special angles like 90 degrees, 180 degrees, 270, and 360, these are cases where we could end up with some undefined functions. And then I also rewrote the Pythagorean theorem here for if we're just trying to find the r. Remember, r is short for the radius, because when we're looking at the coordinate plane, we are looking at different points that would be on the unit circle, which is something my kids will look at a bit further into the future. So when we're looking at the coordinate plane, because we're using x and y values, that means that we're going to be having some different signs depending on where we are in the coordinate plane. So in the first quadrant, my y value, so whatever I'm using for sine, is going to be positive in the first quadrant. The x value, or the cosine, is also going to be positive in the first quadrant. And because tangent is y over x, we would have a positive over a positive, which would leave us with a positive. So in the first quadrant, everything's going to be positive. In the second quadrant, I'm going to the left and up. So because I'm in the upper left, that means I'm going to have a positive y value, but a negative x value. So my sine and cosecant functions are going to be positive. My cosine and secant are going to be negative. And because I'm doing a positive over a negative, my tangent and cotangent are also going to be negative. When it comes to the third quadrant, I'm going down and left, which means I'm going to have a negative y value and a negative x value. Because I would have a negative value over a negative value, that means I would have a positive tangent or cotangent. In the fourth quadrant, because we are going right and down, that means I would have a negative y value, since I'm going down to get to the fourth quadrant. I would have a positive x value, because I'm going to the right. And because I have a negative over a positive, I would end up with a negative tangent or cotangent. So you could see people, there's an acronym that is used in order to see what is positive when. And so that would be all students take calculus. So in the first quadrant, everything, all of the signs are, or all of the trig functions are positive. In the second quadrant, only the sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. So that's a way to kind of remember what's positive when. I always just pay attention to when x and y are positive and negative. I think using that logic is a little bit easier and makes more sense than just trying to memorize a acronym. So when we have angles that are larger than 90 degrees, we are outside of the realm of having a triangle that we can use the whole opposite adjacent hypotenuse thing. So we tend to use the reference angles for those. So we're trying to find the acute angle that is formed from when the terminal side goes to the nearest x-axis, so either the positive or the negative x-axis. Some examples of those. So if I have 300 degrees, in order to get to the nearest x-axis, I would be continuing my rotation counterclockwise. And so I would be creating a triangle by kind of creating a vertical line straight up from the terminal side to the x-axis. And because I'm completing the circle, that means the red plus the blue rotation would be 100 or 360 degrees, which means just my blue part would be 60 degrees. So the amount of space that I went in order to complete that rotation would be 60 degrees. So my reference angle is 60. If I have 225, that means in order to make a triangle, I would be going again up to the nearest x-axis in this case to create that triangle, which means I'm doing a rotation just to that 180 degree mark. If I had a full 225 before, then I'm doing 180 minus the 225 to get just the little blue angle, which would end up being 45 degrees. So for both of these, I could end up using the special right triangle. So for the first one, I would use the 30, 60, 90. And for the second one, I could use a 45, 45, 90 to help me figure out what all of my 6 trig functions might be. For this first example, instead of using a special triangle, they have given us a point. So they tell me it is in standard position. The terminal side is going through -3, -4. All right, so this means that I am going to the point on my coordinate plane that is -3, -4. So I would be going left 3, down 4. And so my angle from the starting position, this is the angle that we don't necessarily know. We just know the point that it goes through. So I'm going to create the triangle so that I have an opposite, an adjacent, a hypotenuse, that kind of thing. I will also see my x, y, and r values. So here my x value is that -3, since we went left 3 in order to get there, and then my y value is going to be that -4. Also the x and y values that are in the point, which is really nice. This means that I need to figure out what my r is. I need to figure out this part right here, which means I can just use the Pythagorean theorem. And I rewrote the Pythagorean theorem above just because I wanted to save myself some time. So I'm doing the square root of -3 squared plus -4 squared. You might also notice that this is one of the Pythagorean triples. So my r is going to end up being 5. And your r is always going to be something that's positive. It's a positive measurement whenever we're looking at that radius. And now that I have my x, y, and r, I can figure out my sine, cosine, tangent. So sine, remember, is y over our r value, so -4 over that 5. Cosine is x over r, so -3 over 5. Tangent is y over x, so we're looking at -4 over -3. And because it's a negative over a negative, this is going to end up being +4 over 3. Because we're in the third quadrant, that does match. So my sine is negative, my cosine is negative, and my tangent is positive. Because it wants all 6 of our trig functions, we're going to do the reciprocal, so we're just flipping everything. So I now have 5 over -4 for my cosecant. Flipping my cosine to get secant, I have 5 over -3. And flipping my cotangent, I have 3 over 4. And we're finished. For our next example, they give me the angle. So my angle is 90 degrees and it wants me to find the functions that way. So it's asking me to figure out which ones are defined and then find those. So some of these are going to be undefined because we're dividing by 0. So I just am going to find all of them and just mark off the ones that are undefined. Makes more sense to me. So 90 degrees, if I'm starting from my terminal side, is just straight up. So we can see that 90 degree, that box there, and make a perfect corner, if you will. So here, when we're looking at this, if I were at any point on this terminal side and I went straight to the x-axis, that means I'd be going straight down. That's our closest point, which means I'm not really making a triangle. So I can't necessarily use the opposite and adjacent and hypotenuse part. I have to rely on my x, y, and r. Because I don't have a triangle, I don't have an opposite and adjacent. And so the r is also going to be standing for the radius. So if I were to draw a circle through this, my radius is going to be the distance from that point to the origin. And so I need a point here in order to do that. I know it's going to be 0, comma something. And this something, it really doesn't matter what it is. You can use any number. My students today decided they wanted to use a number 3. So I'm going to use that again. And so here, that means I have an x of 0, a y of 3. And if I were to try to find the r, that means I'd be doing r is equal to square root of 0 squared plus 3 squared, which means I would just have the square root of 3 squared, which means r is just 3. So then remember, we're just looking at that distance when we're talking about r. So that 3 should make sense. It should be the same as my y value. So going through these, I can, now that I have an x, a y, and an r, I can figure out the sine, cosine, and tangent. So my sine is going to be my y value, the 3, over the r, which was 3 as well, which means that my sine of 90 degrees is going to be 1. Cosine, we're doing the x value, in this case was 0, over r, which was 3. 0 over 3 is just going to give us 0. So this is why you could have picked any number. It doesn't have to be 3. It could have been 7. It could have been 11. Any positive number would have ended up with the same thing. Tangent, we're doing the y value, 3 over the x value, which in this case is 0. So this is why I wanted to talk about if something was defined. So because we're dividing by 0, this is going to be undefined. Cannot divide by 0, so we don't actually have a tangent function. So this is one that we don't really have to worry about. Now we're going to be flipping some stuff, and this is why I made sure to write out everything instead of just saying, oh, it's going to be 1. I write it all out because I'm going to be doing some flipping now. But don't flip out. So I'm going to be flipping my sign in order to get my cosecant. So I've got the r over y, which is still 3 over 3, so I'm still going to have 1. With my secant, I'm flipping my cosine, which means I now have the radius of 3 over my x, which is 0, which means this one's now undefined. So the secant we don't actually have to worry about since it's not defined. In my cotangent, I'm still flipping my y over my x to get x over y, which means I have 0 over 3 now, which is defined. It is 0. So this is why I like to write it out so then I can see all of that flipping action whenever I go from 1 to the reciprocal. And then that's it. We're done. I have my actual values that we could find, and I crossed out the ones that would be undefined. My next situation, they want me to rewrite the sine of 130 degrees as a function of acute angle. So an acute angle is something that's smaller than 90 degrees. So that means I'm going to first figure out the reference angle for 130 degrees. That's what we mean by the acute. We're looking at the reference, so that alpha. I know 130 degrees is inside, in between 90 and 180. I'm not going to make it very specific right here. I just want to kind of get through it, I guess. So in order to get the reference angle, that means I'm dropping down to the x. So this will be my alpha. If this is 180 degrees, that means I would have moved 50 degrees in order to get to that 180 from the 130. I also need to pay attention to what quadrant this is in. So this is in quadrant 2. I'm paying attention to this because things aren't always positive or negative in the signs, are not always the same as in the first quadrant. So 50 degrees is in the first quadrant. Everything's positive in the first quadrant. In quadrant 2, however, not everything is positive. So quadrant 2, I'm looking specifically at sine. Fortunately, if you didn't pay attention to it, sine is positive in the second quadrant. So I don't have to worry about changing the sign from positive to negative because first and second quadrant are going to be the same. So writing this as an acute angle, I'm looking at the sine of 50 degrees. This will be the same as the sine of 130 degrees. They should both be positive, so I don't have to worry about changing the sign. Say that I was looking at the cosine instead, and cosine is negative in the second quadrant, I would have just put a negative sign out in front. And so we're done. If you were to plug this into your calculator, making sure that your calculator is in degrees, you would end up with the same thing for both. It's going to be a gross number, but it's going to be the same gross number. Next, they want us to find the exact value for tangent of 135. So exact value means we're not just plugging it into our calculator and finding the decimal, because the decimal is not going to be something that's pretty. So we want to find the exact value. We are likely going to have to use one of the special right triangles in this case. So 135 degrees, I know that's somewhere in the second quadrant. I'm going to figure out what the reference angle is to see if I can use one of the special triangles. And my reference angle here would be 45 degrees, which means I'm looking at a special 45, 45, 90 triangle. The special thing about 45, 45, 90 is because we have the same angles, the 45 and the 45, that means that their sides are going to be equivalent. Because I'm in the second quadrant though, the one that's in the x value is going to be a negative. So I can represent those with positive and negative 1. So my x here is -1, my y would be +1, and then our radius would be square root 2. So those are the special ratios for those sides for the special right 45, 45, 90 triangle. And because I'm doing the tangent, that means I'm doing the x over the y, or sorry, the y over the x value. So I have a +1 for my y, -1 for my x. So the tangent of 135 degrees is just -1. So for my next example, we're looking at, they want us to find the 5 other trigonometric functions of theta if we have our sine theta of -3/4 and our angle is somewhere in between 180 and 270 degrees. So when they tell me the 180 through 270, that means that we're looking in the third quadrant. So I'm going to go ahead and draw a little angle in the third quadrant. And they've told me the sine is -3/4, which means they've told me my y value and my r value. I know that r is always positive, so then it's the 3 that's negative. So -3 and 4, which means I need to try to figure out what the heck my x value is going to be. This isn't one of the special Pythagorean triples because the 5, it's 3, 4, 5. The 5 would be the hypotenuse. In this case, 4 is the hypotenuse. So we don't actually have one of the Pythagorean triples. So I do have to try to solve this out. So I would have 4 squared is equal to my x squared plus the -3 squared. So I would have 16 equal to x squared plus 9. So 7 would be equal to x squared, which means square root of 7 is my x. And because my square root of 7 is over to the left, this means it's going to be a negative square root 7. Now that I have my x, y, and my r, I have all those values, I can do all 6 of my all of my trig functions. All the trig functions. So they already told me the sign, which is really nice. -3/4. My cosine is going to be the x value, so negative square root 7 over my r of 4. And tangent, we're doing y over x, so -3 over negative square root 7. So my negative and negative would give me a positive, and we can't leave the negative or the square root 7 in the bottom, so we'll rationalize it to 3 square root 7 over 7. Now it's time for the reciprocal, so I'm flipping everything. Reciprocal of sine, my cosecant would be 4 over -3. The reciprocal of cosine, my secant, would be 4 over negative square root 7. Again, we have to rationalize this, so it'd be 4 root 7 over 7, still negative. And then the reciprocal of my tangent, aka my cotangent, I'm going to be flipping. I like to flip the original, it makes more sense to me, and then that way I don't have to rationalize again because it would just be negative square root 7 over -3 or square root 7 over 3. And we're finished. And these are my last two. So here they want us to find the exact value. You could plug it in to see if it was something nice like that tangent was earlier. If you do though, this one actually ends up being a really gross decimal. So I'm going to do kind of the similar method of what I did before. So we're going to graph as well as we can 315 degrees, which is in my fourth quadrant. It's in between 270 and 360 degrees. So this is my 315 degrees, which means I need to figure out my reference angle. So if I went the rest of the way to 360, that means I would have moved 45 degrees. So this means I'm looking at a 45, 45, 90 triangle. So 45, 45, 90, that means my sides are the same. So 1 and 1. Because I went to the right, that means this is a positive 1. And this would be a negative 1 since we're going down. And my hypotenuse here is going to be a square root 2 for that 45, 45, 90 triangle. So my x, my y, and my r. Because we're looking at sine, that means that we're looking at the y over our r value. So in this case, it's negative 1 as my y value over my r, which was square root 2. Rationalizing this, I end up with a negative square root 2 over 2. Definitely not something that would be pretty in the calculator. And then my very last, we're looking at cotangent of negative 30 degrees. So negative 30, that means I'm going clockwise. So I'm going clockwise 30 degrees. This is negative 30 degrees right here. Which again, if I'm doing my reference angle, that means I'm going straight back to the x-axis. So if I moved negative 30 degrees, if I go the opposite direction, that means my alpha is going to be a positive 30 degrees. So I'm going to draw this out kind of over here since I overstayed my welcome a bit. So this is 30 degrees here, a positive, which means I have a 30, 60, 90 triangle. My 30, 60, 90 triangle, across from the 30, I would have 1. Because we went down for that, we would end up with a negative 1 for our y value. Our hypotenuse here is going to be 2. And my x value, anything that's across from my 60, is going to be a square root 3. And because it's going to the right, it's going to be a positive square root 3. So this is my x value. Whenever it comes to the cotangent, cotangent is my x over my y, which means I'm looking at my x was square root 3, and my y we found was negative 1. So then the cotangent of negative 30 degrees is going to be negative square root 3. So we're using those reference angles and finding the special right triangles that goes with these, and using those ratios that are common for those. Now this is all that I have for today. My students can find their work in the LMS page. Whether you are my student or not, please like, share, and subscribe, especially share if you know of someone who is struggling with something like this and needs a little bit of extra help. Be sure to share the love.